Hi, welcome to Coffee and Astronomy. I'm Jim Craig, and today I want to talk a little bit about seeing. If you're into astronomy, it helps if you have reasonable eyesight. I do know some people who their eyesight isn't that great, but they still manage to do astronomy. But I'm not talking about our seeing. I'm talking about the sky. We all know that on a cloudy night, you're not going to go out and see any stars because even the best telescopes aren't X-ray telescopes, at least not ones we have here on Earth. And unless you've got Hubble money for sending something up above the atmosphere, you're going to fall victim to clouds. But there's more to it than just the clouds. I have an app on my phone that I use. It's called Astrospheric, and I'm going to show a screenshot of it. I'm going to explain some of the things that you see right here. For example, cloud cover. Now I've got this set to look at next Tuesday at 1 in the morning because that's the first time when the sky is actually really clear. But if you look before then, you're going to see that even though the cloud cover, which is the top blue line there, is clear, next to transparency is considered average, but that white, if you look at look over here, you're going to see the seeing is below average. Now, what all those things mean? Cloud cover is obvious. You go out, you look up, you see clouds. The next is transparency. The atmosphere is more than just clouds and air. We also have water vapor in the air, and sometimes that water vapor will scatter the light and make things harder to see, so the atmosphere isn't quite as transparent. Usually the best transparency occurs when the weather is really, really cold, because it's at that point it's either going to be clouds made of ice crystals or no moisture in the air at all. Now, I happen to live in the Carolinas, and we have a real problem with humidity, especially in August. August, the transparency of the atmosphere is really bad. But the last one that you saw there is called seeing. And our atmosphere isn't one big solid block of air that doesn't move. The air is constantly moving, and it has turbulence. And based on the turbulence, you have little pockets where the air is slightly more dense than in other parts. And as that goes through, the density affects how the light goes through it. It's called an index of refraction. And denser air will have a higher index of refraction than less dense air. And that means that you'll see, if you look at a star through a telescope or a pair of binoculars, you're going to see it scintillating. Or if you just look at it naked eye, that's what makes stars twinkle. It's not the stars themselves. The stars themselves, the light is shining nice and steady. But as it comes through the atmosphere, the different layers of atmosphere at different density passing through over one another, that sort of thing, that's going to affect how the stars look. If you go out on a night and the stars aren't twinkling, that's the time to get out your telescope. Now, that doesn't mean your telescope is unusable when the seeing is below average or average. If it's above average, great. But if the seeing is average, you can still go out. You can look at things. You can see nebulae. This seeing does not really affect nebulae that much. It does scatter some of the fainter wavelengths or fainter bits of light, but it doesn't affect nebulae that much. What it's going to affect is if you try to take a picture of something, your stars, instead of being pinpoints, are going to be big blobs. If you try to do astrophotography with the planets, you're going to have to take a lot of frames. Now, I've got a piece of video that I'm going to show here that shows what bad seeing can do to a planet, but what image processing can do to bring it out. This is the video as I shot it. It has been converted to a form that I can show here on YouTube, because it's what's called an SER file, which is pretty specifically for astrophotography. I had to convert it over to something that could be used on YouTube. But you can see this planet is just, the atmosphere is causing it to look like it's moving all over the place. Now, with just a little bit of image processing, I was able to take that video and turn it into this image. And you can see there is really a lot of detail that came out, but that's about 2 minutes of video shot at over 100 frames per second. So this is tens of thousands of frames, and I only save 15% of them. The software I use averages out the best, takes the best images of those 15,000 or so that I shot, and then averages those together to get the best image. And then I do a little bit more processing to bring out some of the detail. So if there are no clouds in the sky and you can see the stars, you can still do astronomy. But if you want to do astrophotography, if you want the best views, then get a piece of software like the one I'm using here, Astrospheric. There's other ones that I've got here on my phone. I've got Clear Outside, and there are several others. Next week, I am planning to do I won't call it a gift buying guide, but my guide to buying a telescope, because like it or not, the holidays are coming up on us very rapidly, and now is the time to order in order to get things in time for the holidays. So next week, I hope you'll tune in to Coffee and Astronomy so you can take a look to see what I've got in mind, some ideas to help you figure out which kind of telescope you might want to get if you want to get a telescope for the holidays. As always, gotta sort of put my hat in my hand and ask folks to consider making a contribution on my Patreon page. You can become a patron for as little as $1 a month. That will give you access to exclusive content, occasional prize drawings, and direct access to me. So if you have a question, you can ask me directly, and I will answer it either in Coffee and Astronomy, I'll send you a message directly, or maybe you can join us for Pints and Planets that we do on Friday evenings. So until next Sunday, enjoy your coffee, do some astronomy.